we're going to look at writing a kind of a general expression for a coterminal angle. So there's a space later on here that says this, whatever page that is, page 130 or something like that. If you have an angle, let's get rid of that arc for a second. So we have an angle here somewhere, right? If you see where I've started, so if I start here and then I rotate around to here, you might know that that angle is something. What is that angle? Let's see here. I mean, that could be that angle, right? But if you didn't see me rotate it over to there, that could be the angle, or that could be the angle. If it's just ended here, there's a lot of different angles it could be, right? It could actually be once around and then there. Could be a million times around and then there. Could have been backwards, anything like that. So any angle that ends there, you call them all coterminal. We want to be able to, or we have to be able to write an expression for all the angles that end there. If that happens to be, did I put the degrees here? No, I didn't. Oh, yes, I did. Well, let's make it an easy number to work with first. Let's make it 130 degrees, if possible. Well, that's as close as we can get. But okay, so if you have an angle of 130 degrees, maybe draw that here. Okay, so you have this is 130. So there's one angle that could be. Something else that's coterminal with that, if you went once around and then ended there, what would that be? Yeah, not adding on another 360. So what's that? 490. And then if we keep going here, if we did 2 times around and then there, what would that be? $850 or something like that. You could keep adding, adding on. You could also put angles the other way, of course, right? If you went backwards, we said there, what would that one be? If you went around backwards. We'll get rid of some of these lines here. Sorry, what was that? 230 or something like that? Negative 230? Negative 230 degrees. This could keep going this way too. If you want to write an expression for that, the way you can write that is, you could say that it's pick one of them, and then adding on multiples of 360. Or algebraically, the way you'd say it is you'd say 130 degrees plus n times 360. Or since mathematicians like to write things in certain orders for who knows what reason, they like to put the numbers first, 360n. This is an expression for all the angles that are coterminal with that. I should probably say where n is an integer, though. Especially if you're thinking of writing the provincial exam, they like to look for stuff like this. Okay, so that's just an expression. It's a way of saying them. If you had to list them all, how many angles are there that are coterminal with that angle? Yeah, an infinite number, right? So you can't do it by listing them all like this. I mean, that's a way of giving an indication, but it's leaving the pattern up to somebody to understand. Here it's saying what the pattern is. It's start there and add that. You could start, like we could have picked this one as the starting point, so instead you could put 490 there. Probably best to pick the smallest positive angle and work from there. Okay, that being the smallest positive angle, and then add the multiples there. If it was in radians, let's do one in radians here. So if you had an angle that over here, let's say you have an angle there that is, what might that be? That might be, let's say if this was pi over 6, then what's that angle? If this little angle in here is pi over 6, then that is 7 pi over 6. How could you write an expression for everything that's coterminal with that? What would the next one be? What would that one be? Nice circles, eh? How much do you add on when you're working in radians? Yeah, you're on 2 pi, and you're at 19 pi, right? 19 pi over 6. Because you're 7 pi over 6 plus 2 pi. 2 pi is like 12 pi over 6. When you're working with this, if you're working with sixths, think of 2 pi as 12/6, right? 2, and then you got your 19 pi over 6 there. So if you're wanting to express this, you can, instead of making a list like this, what would the next one be? Next one would be, you got another 12 on there. 31 pi over 6, ... If you went back the other way, what would the first negative one be? The picture, I think, helps in your mind. If you went backwards here, instead of 7/6 this way, this is going to be negative 5/6 that way, right? Because there's 12 all the way around. ... that way. Again, you don't want to be able to, if you have to write it as a list, you can't list them all. If you want to write an expression here, you can say it's 7 pi over 6 plus multiples of 2 pi. Or in other words, if you're writing it algebraically, 7 pi over 6 plus 2 times pi times n, where n is an integer. You don't need to say plus or minus 2 pi n because integer includes all the negatives. So that's how to write. This is how to write, how to define this sequence of numbers. You probably have that concept before, right? Like if you just think about any regular numbers, you can, if you wanted to write these numbers down, 4, 7, we'll put the first one there, negative 2, ... that way, 7, 10, 13. How can you express that as a single expression without making the list like that? You could do the same as you did up here. Pick one of them, maybe this one. 1 plus, what are the jumps here? 3, right? Plus 3n. This is just, this is when you wrote linear equations and you said y equals 3x plus 1. That's all you're doing. You're giving a general expression for all the numbers rather than listing them all. It's the same thing here. This is a general expression for all of the angles, right? When you did sequences and you summed it up like that. So I don't think it's as hard as you might think initially here. That's just kind of the distance in between them, or what we're going to call eventually the period in between those numbers, kind of the space there. We're okay with that? Coterminal angles. One other thing we have to look at is the reference angle. I'm going to stop this first before I run out of time.